Okay, so we know how to find the derivative of sine of x, right? We know how to find the derivative of 2x minus 4. But do we know how to find the derivative of sine of x squared minus 4, right? So I know how to find the derivative of sine x separately. That's cosine x. I know how to find the derivative of x squared minus 4. That's just 2x. But now when it's sine of x squared minus 4, when it's a composite function, can I find the derivative? In order to be able to do that, we have to use what we call the chain rule, okay? And by far, the number of functions you can differentiate without the chain rule versus the number of functions you have to use the chain rule for, like they don't even compare. Almost every single function that you will come across is one where you have to use the chain rule. Yeah.
So I'm confused because couldn't you just distribute and say like, okay, sine of x squared minus sine of 4?
Because sine of x squared minus 4.
Oh, with our rules.
Yeah. So okay. So I'll tell you this: sine of a plus b.
We can do that.
Is that the same as sine of a plus sine of b? Sine a cosine b plus cosine sine. So it's sine cosine cosine sine.
But using that, we actually could differentiate it. Right?
Using that, you could differentiate. It would be the product rule. The product rule. Okay, fine. But now, what if it's the square root of x squared minus 4? What are you going to do then? You don't have a sum and difference formula for that. You need the chain rule. So there comes a point where you can't get away with it. You must use the chain rule. Okay? So here's what the chain rule is. Okay. Look at sine of x squared plus 4. Basically, when I zoom out, that looks to me like sine of some function. So on the outside, I have sine of some function. And then when I zoom in, I see, oh, inside, there is another function, x squared minus 4. So there is this outer function of sine x, and then there is this inner function of x squared minus 4. That's the key. That's the key, to be able to tell apart the outer function from the inner function. Okay? So, exactly. That's why I take so long to do that, f of g of x, and find, remember I would give you like a composite function. I would say find f and g such that f of g of x is this. Okay, so now, if I have, you want to step outside? Okay, if I have f of g of x, the way I find the derivative is f prime g of x. So this is the derivative of the outer function times the derivative of the inner function. Okay, so it's the derivative of the outer function, the derivative of the inner function. Now, if y is f of u and u is g of x, dy dx, this is called Leibniz notation. So Leibniz found, he invented calculus as well, simultaneously as Newton. But at those times, it's like, even now, you have to be the first one to publish in order to get credit, right? So Newton kind of beat him to it, and he got all the credit. It's like there was always these things. Einstein ran into them, like, you know, it's whoever published first gets the credit. But Leibniz did it as well, and he has, you know, his own notation. So dy dx is dy du, so the derivative of the outer function, and then du dx. Okay. All right. Let's just do a couple. So first, the first thing you have to do is find the outer function and find the inner function. Let's do some examples, and then this will make sense to you. You won't even need it to make sense once we do some examples. So this is the function here, right? It's cosine of x squared minus 1. So cosine is the outer function. X squared minus 1 is the inner function, which we usually refer to u because y is, f of u. In the first couple of problems, I was nice and I gave you the inner function, but you are going to have to recognize them, after the first two. So now dy dx is the derivative of the outer function. And now look, what's the derivative of cosine? Okay, it has to be negative sine of this whole thing, x squared minus 1. That's the key. And then you multiply with the derivative of the inside function, 2x. So finally, we normally write the algebraic functions first and then the trig, so it's negative 2x sine x squared minus 1.
Why did you keep the x squared minus 1? I thought the outer function would just be cosine of x.
No, because it's cosine of x squared minus 1. And all of these, look, it's f prime of g of x. Okay? So you have to keep that one. Otherwise, you're changing the problem. That is just derivative of cosine x. Okay? All right, let's do this next one. The outer function is sine of x. So this is the outer function.
Or would it be sine of x or sine of
Root x, hang on. And then the inner function is this one. So now dy dx is negative cosine root x. Cosine root x. And then times, okay, the inner function is root x, which is x to the half, right? So now I need to take a derivative of x to the half. In the beginning especially, it's worthwhile to just write it like that. So the derivative of x to the half is 1/2 x to the negative 1/2 because you subtract 1. So it's going to be 1/2 times x to the power of 1/2 minus 1, right? You bring down the power and you subtract 1. So that'll be negative 1/2. So that's cosine root x times 1/2 x to the negative 1/2, which means when you rewrite it, dy dx, it will look like in the numerator I have cosine root x, and then look, the 2, it's 1/2, right? So 2 is in the denominator, and so is the x, because x to the negative 1/2 is 1/x to the positive 1/2. And so, yeah, so cosine root x over 2 root x. Okay? Yeah.
Why did they write it with dy dv?
Because it's the derivative of y, it's the derivative of the outer function in terms of u, the inner function. So it's the derivative of sine, which you get cosine, in terms of u, root x. Okay? And then that's the derivative of u with respect to x. Okay. All right. An object moves along the x-axis so that its position at any time t is greater than 0 is given by x of t is equal to this, right? Cosine. Find the velocity of the object as a function of t. So velocity, we know, is just x prime of t. So the outer function is cosine. When I take a derivative of cosine, it's negative sine t squared plus 1 times the derivative of the inner function, 2t. So v of t is negative 2t sine t squared plus 1. Okay. Okay, so outside inside rule. So basically this is what I've been talking about this whole time. When you have dy dx, right? So first you have to find the derivative of the outside function, but you have to keep the inside the same. That is not how you spell inside.
So you're saying that
And then multiply by the derivative of the inside.
this is the same thing.
It's the same thing. Yeah.
So the derivative is it's f prime of x when x is equal to the inner function.
So it's f prime of g of x.
Yeah, because you're saying you want the instantaneous slope at that function.
Okay. So here we go. dy dx. dy dx. You can get nowhere unless you try you figure out which one is the outer and which one is the inner. So what's outer here? What's inner? 3x. Okay, so dy dx, here's how I'd like to do it, is cosine, right? I take a derivative. Okay, go step outside, finish that up. So here's how I do it. Derivative of the cosine, right? I take a derivative of the cosine and I get negative sine 3x. And then just so I don't get confused, I kind of like cross it out. Okay? And now I need to find the derivative of the inside, so times 3. So that'll get me negative 3 sine 3x.
Can I just write y down?
Yeah, they're interchangeable. So here, dy dx is derivative of the sine. I get cosine of x squared plus x times derivative of the inside, 2x plus 1. And again, it's convention to write the algebraic function first. It looks nicer, it's better. Okay. Now, this is too simple a problem. Because now what if you have sine of, cosine of, tangent of 2x, right? So one nested in another and another and another. That's when we do the repeated use of the chain rule. Sometimes we just have to do it more than once. So look at this one. On the outside, I have tangent. I zoom in. Okay, so that's my first function, is the tangent. I zoom in, and I have 5 minus sine of 2t. That's my second function. But wait. There's more, because it's sine 2t. There is yet another one. There is 2t inside the sine, right? So now I have to do the derivative of the first one with respect to the whole thing, the derivative of the second one with respect to what's inside, and then the third one. So let's do it. So ddx of this whole thing. Now, this function was not given a name like y or f or whatever. So it's ddx of the whole thing equal to, okay, so first I take a derivative of the outermost function tangent, and the derivative of tangent is secant squared. So it's secant squared of everything. Okay? Then times the blue. So the derivative of 5 is 0 minus cosine 2t times the derivative of 2t is just 2.
Wait, what? Oh, okay, because if it was just t, you would have
If it was just t, you wouldn't have had to do that. So let's just clean it up a little bit. This is negative 2 cosine 2t, if I wrote the blue and the red first, times secant squared 5 minus sine 2t. Yes, sir.
Why do you have the times 2?
Because that was the derivative of 2t that you just mentioned. Right. Right? Because sine, it's not sine of t, it's sine of 2t. So I need to take the derivative of sine of 2t times 2. Yeah. Okay. All right. So what if you have a power with the chain rule? So power channel, suppose you need to find ddx of u to the n, but u is not just x, it's a whole function of its own, right? Like the square root of x or something like that. So what you would do is the n will come down just like before, and then you subtract by n, n by 1, right? And then you still have to find the derivative of u. Okay, so take a look at this one. I have the square root of tangent of 5x. So do you see how there is a square root? Inside there is a tangent. Inside there is a 5x. Okay, first I like to rewrite this as tangent 5x to the 1/2. So now what are my functions? I have the 1/2, that's my first function. That's the outermost function, right? The outermost function is 1/2. Then inner function, I have tangent. And then yet another inner, I have what? 5x. So first, for y prime, I bring down the half. So it's 1/2 of this thing, right? Tangent 5x to the power of what? Negative 1/2, because it's half minus 1. Times. Okay, so now I'm done with that one. I could cross it out. Next I have tangent 5x, which is secant squared 5x, right? The whole darn thing. Times the derivative of the 5x is 5. So, yeah, exactly. You see why it's called the chain rule? Because it's literally like chained.
And then you just multiply them all out.
You just multiply them all out. So now look, I have a 5 and a 2. So I'm going to have a fraction again. So I have a 5 on top, 2 on the bottom. Secant squared 5x on top. And then the red tangent to the negative half, that's a denominator, and it's a square root. So it's over root tangent 5x. Okay? Right? Yeah.
So it's 5 over 2, secant squared 5x over 2.
It's like this. Okay? Okay, so let's do this one. Okay, I'm making a screencast. Multiplying, yeah. Okay, so here, 2 is the outer function, right? So we'll call that the first function, the square. Inside, I have this. And third, inside of that is 2x. Okay, so y prime. The 2 is going to come down. So I have 2 times this whole thing to the power of 1 times, now the second function. What's the derivative of this inside the parentheses? Minus sine 2x, good, times 2. So let's clean it up. negative 4 sine 2x, 1 plus cosine 2x. Isn't that fun?
Yeah.
Okay. Oh, look at this next one. Look at this next one. What?
Yeah, would you
Whoa.
like make it so
Are
we
there four
separate them
steps
and
I
then
see?
do the rule we used last chapter? Where it's the x
It's the multiplying rule.
Yes.
The
Hey, see that?
pieces are increasing.
There we go.
So you
Now,
take x cubed.
now we have the product rule, but
What?
within the product
Oh
rule,
my
we
God.
have the chain rule, guys. Oh my God.
It's better.
Okay. All right. So u
Is x cubed.
is x cubed. V 2x minus 5 to the power of 4. Now, u prime 3x squared. Okay? Wait, like last time, like when we were doing this, you thought that was your biggest problem, right? And now look at this. Now, v prime, what's the outer function? The 4. So that'll be 4 2x minus 5 to the power of 3. Okay, so that I'm done with that. And now the derivative of this times 2.
Wait, what are we?
This way, I squared.
Okay, so we had to find u and v,
Yeah. And then
v prime. But in taking a derivative of v, you notice that that's a chain rule. You see that? So it's like, so, you know, it's like
so you're not taking the
3
chain rule of like product, you're doing the product rule.
of a chain rule. Yeah, yeah. Okay, so now y prime is u prime v, right? So it's 3x squared times 2x minus 5 to the 4 plus uv prime. So look, from here I have 2 times 4, 8, x cubed, 2x minus 5 cubed. Right? So what I did basically, I simplified at the same time. So I multiplied this diagonal first, then I multiplied that diagonal. Okay, and I rearranged at the same time. But now, here's why, again, in Pre-Calc Honors, I go over this. Okay. We can simplify this further because we can factor stuff out here, right? So here, I can factor out an x squared, and what else can I factor out?
2x minus 5 to the third.
2x minus 5 to the third. So y prime is, I'm going to factor out an x squared and 2x minus 5 to the third. Now, factoring out is like dividing each term by what you're factoring out. All right? So, here, when I factor this out, I get 3, 2x minus 5, plus 8x, that's it. And then I can simplify that even further. So y prime is x squared, 2x minus 5 cubed, and then I distribute the 3. So I have 6x plus 8x, 14x minus 15. Yep. And okay, so this might be a multiple choice question. And then, you know, the answer will be like what I've boxed. So you have to work like super fast and then get it into that. Okay, find the slope of the line tangent to the curve sine to the 5x at the point where x equals pi over 3. Okay, At first glance, you know, to the untrained eye, this does not look like a chain rule problem. Eventually, you will recognize very quickly that this is a chain rule problem. However, when I rewrite this as sine of x to the power of 5, now we can recognize more quickly that that's a chain rule problem. Okay? Because what's the outer function?
5.
The exponent of 5, and the inner function sine x. So if I want the slope of the line tangent to the curve, I just want the derivative at that point. So dy dx is 5 sine x to the 4, so now I did the 5, times the derivative of the inside, cosine x. Okay, now I'm fine leaving it like this. I have to evaluate it at pi over 3. Okay, so now I say dy dx evaluated at x equals pi over 3 is equal to, yeah, y.
Wait, I'm so sorry.
Uh-huh.
You wrote dy over dx, and then you do a line through like
A vertical bar, meaning evaluated at, that's what that means, evaluated at x equals pi over 3, bottom right. Uh-huh. Mathematicians are nothing if not efficient in our notation, right? In their notation. So, I mean, there we go. So times cosine pi over 3. So this is 5 times. Pi over 3 is, sine of pi over 3 is root 3 over 2 to the power of 4. Cosine of pi over 3 then must be the other one, which is a half. Okay, so in the numerator, I have 5 times root 3 to the 4. Root 3 squared is 3. Root 3 to the 4 is 9. So 5 times 9 is 45. Over 2 to the 4 is what these days?
No,
16 times 2 is 32. So that's it. So what we have found, once we take a derivative, it's not to the 4.
So
Okay, what we have found now is the slope of the tangent line to this curve at pi over 3. So if I were to graph sine of x to the 5 and get my curve, when I go to pi over 3, it's going to have a positive slope of 45 over 32. So the slope is going to be 1 point something. Okay? Cool.
And then you have to get your y value.
Well, no, it doesn't say that. It just says find the slope.
You are right.
It's not asking for the equation of the tangent line. Okay? All right. Show that the slope of every line tangent to the curve y is positive. Okay, fine. Show that the slope of every line tangent to the curve is blah. Okay, in order to show anything about the line tangent to the curve, I first have to find the line tangent to the curve. So first, why don't we find that one? Now, here's another question. Do I need to find the actual line?
No.
Okay, so I need to show that the slope of every line tangent to this is positive. So the slope, I need to show that the slope is always positive. Okay? So let's find dy dx. Okay, so let me write y in a more, in a better form. So it's 1 over 1 minus 2x to the 3, which is 1 minus 2x to the negative 3. Okay?
So you take out the negative 3.
So now negative 3 comes down, dy dx.
Times 1 minus 2x and negative 4.
Okay, yeah. So negative 3, 1 minus 2x to the negative 4, times what?
Negative 2.
Times negative 2. Is everybody okay with this? Okay, So what do I have now? I have negative 3 times negative 2 is 6. Negative exponent means move it down. 1 minus 2x to the power of 4.
Did we just show it?
We just showed it, but you have to say it. This means nothing. This means you could find the derivative. Now we have to say, since the numerator and the denominator are both always positive, right? 6 is always positive. Anything to the power of 4 is always positive. Their quotient is also always positive. Again, you have to define your pronoun, right? If you say it, they, he, she, there must be something that it refers to. Okay, those words refer to. Oh my God, this next one. Oh my God, these are my favorite. Like absolutely my favorite. Oh my God, I love these. They're like little pieces of a puzzle. You'll love them too. Okay. So, use the table of values to evaluate the following. So basically this is saying the derivative of f of x times g of x at x equals 1. Now, the derivative of f of x times g of x is a product rule, right? So, you have two functions being multiplied by each other, and you want to take a derivative. So, u is f of x, v is g of x. So, u prime is f prime, and g prime. So basically, by definition, d dx, this is f prime of x times g prime of x plus, no, I'm sorry, I rushed. F prime of x times g of x plus f of x times g prime of x. But we have to do it at x equals 1. So it's f prime of 1 times g of 1 plus f of 1 times g prime of 1. And then you just have to go and like find them in the chart. No. This is like given this chart.
This is for a certain.
Oh,
it's not always going to be.
It's not always going to be that. No. It's not always going to be that. So given this scenario, so now f prime of 1 is 5 over 3. G of 1 is 1.
Wait, f prime of 1 is 5 over 3?
Yeah, so
it says it on the bottom.
5 over 3 times 1 plus 1, no, over 3 times what's g prime of 1? 2/3. So it's 5/3 plus 2/9, right? Which is 17 over 9.
No, so not.
Okay. So let's do, is Passover 50? Okay, let's do D. Let's do D. It's the derivative of f of g of x. This is chain rule. So this is f prime of g of 4
Times g prime of 4.
times g prime of 4.
Is that it?
No. Now look at this one now. F prime of, what's g of 4? Negative 1/3. So I have to go one more time. Times g prime of 4. What's g prime of 4? Negative 1/3. So this is, what's f prime of negative 1 over 3? Wait, how did I?
No, that makes sense.
No.
I mean, if you wanted to try before.